Oh, I guess it's recording right now. Hi everyone, I'm going to introduce a little bit about my final project, and it's a speech to text conversion project. I'm going to take the audio clips like the WAV files into as input and then to transform it into the text of the speech. And now I'm going to show my structure and the codes of my final project. Thank you very much. And first, I'm going to show the demos through the Visual Studio Code. I'm about to do that in my GitHub, but I'm still uploading my files to the GitHub. It's taking a while. So I decided to show the results through the Visual Studio Code. And that's literally the same thing because I got exactly the same code and the same stuff from the here and the GitHub. So now I'm going to open the website. I can transform to the studios. Okay, now that's the front surface of the app, the website, and it shows the speech to text converter. And what I'm going to do, how to use it, is to choose a file. And here's some examples I provided to as the input. First, I'm going to use test. And by clicking the button convert, you will automatically get the text after a while to get the text of the speech. Like here, the stale smell of old beer lingers, blah, blah, blah. And I also designed a button to listen to the uploaded file, but it failed right now, and I'm very sorry for that. And I'm still looking for the errors. It might be something with the code of the HTML and the server. I believe there's like a contradiction between the code I use, like the JavaScript code in HTML with the server I'm using. So I'm trying to figure it out in later days. So we can listen to the uploaded file by now, but we can listen to the file over here by checking the accuracy of how the speech is converted.
The stale smell of old beer lingers.
It takes heat to bring out the odor.
A cold dip restores health and zest.
A salt pickle tastes fine with ham.
Tacos al pastor are my favorite.
A zestful food is the hot cross bun.
Okay, it seems works pretty good. So now I'm going to show a little bit about code and to see the structure of the system. And first, I'm going to introduce my backend structure, which I use the Python Flask because I think it's like a very straightforward way to design, and it's really good at processing the files from the HTML. And here's the code of the Flask, and there are some functions. The first function is to check the files. It's actually in WB files, and there's a function for the speech to text conversion. And also there are files to process the files from the HTML, the front end of the whole system. And all these functions, they form to become the backend of the whole system. And by introducing the backend, now I'm going to introduce different blocks that I use to support the whole function. And they are not major, like useful for the whole function, but they are just the blocks that's functioning as a support, that's really essential for the final result. The first one, and this is also the first function, is called audio denoising block. And in this block, there's a function called denoise, where I can get rid of the noisy background noises and get pure human voices by using this function. And the algorithm I use is the independent component analysis, which is also called the SCA. And by using these components, I can the input should be a mixed source of audio clips, and I can get pure human sounds by running through the function. So the output should be the denoise audio. And this is audio I will use for the second part, that's the vocal event detection. By vocal event detection, I'm going to, in this part, I'm going to check the background voices and to determine and label them and to see like in which backgrounds the man is talking, like the speech is happening. And this is not really useful for my final function. This is actually prepared for my third block, that's the speech detection. So that this one helps me to distinguish the speech from the background voices. And I'm doing here is to label the background voices into different into different scenes, and now going to run the training to see what the background voices this be. And the data I'm using is called EAR, and this is open source that contains of different background environments, and it's really good for training for this topic. And I picked 500 for the training loader label, and 50 for tests and 50 for validations. And here is the code I used to load the data and to create the training and the testing. And the major structure I use is the AlexNet. It's a really powerful structure that has different filters that really fits with me. And the network I use is the CNN network, and it also fits me perfectly. And I also tried with RNN with LSTM, but the CNN gets some better accuracy. And here's the code for the AlexNet structure and the CNN classifier. And by using this model and then running the data set from what I get of the train loaders and the validation loaders, and I get results to, here's the iterations for like 100 times, and the accuracy is counted for each one. And the final accuracy is around 75%, and you see you can distinguish between different background voices like the beach, the cafe area, car, city center, and etc. So it's performing pretty good. And by distinguishing the background voices, I can now distinguish like whether there's a speech or not. And this is what I'm going to do in the speech detection block. And first, I use a similar way to do the speech detection block and comparing to the vocal event detection. And I also use the AlexNet architecture, and the data I use is called Lear Speech, and it's open source for English environments and English speech. So I also take 500 for training, 50 for validation, and 50 for test. And here's the code for the data collection. And here is the major AlexNet structure. It's literally the same, but some filters it changed. Like the last filters is normalized. That's like the major difference between the speech detection and vocal event detection. And by training after training the system, it can, for also 100 iterations, it can also determine whether the overall accuracy reaches like 100%. That's like really astonished to me. And so it means like the computer can distinguish whether the audio clip contains speech or not. If there's no speech, it won't process. So that's like the major function of this block. So I'm going to show an example. Like I'm going to choose a file that contains no speech. Like here I prepared an example that contains no speech. That's pure background noises. And then I'm going to put it into my speech to text converter to see the results. Convert. And it will tell you could not understand. So that's like the major function of this block. And also we'll try one with speech. You will see it functions again. So you can distinguish whether there's a speech or not, which may be used sort of together here. Go check with it.
Which maybe you sorted he had to keep on performing because the tenderfoot was still in the saddle.
Okay. And so that's it. And for the last part, I'm going to show the code for the HTML, and I believe that will be the end of the introduction of my project. And the code of the HTML is over here. And for the later part, I'm going to finish the report. I'm going to check whether the error of the button of video uploaded. I will check the errors to that part, and that will be the final steps of my final project. Thank you very much.